Okay, welcome. We're getting going here. My name is Clarence Twitchell. I'm the room host for this room, and appreciate Jeremy being here to tell us all about MongoDB and New York. So thank you very much. Here you go.
Okay, thank you. There are candy canes for the guests. The other rooms don't have that, so this is definitely one you made the right choice to be here. So as Clarence said, my name is Jeremy. Flew in from New York last night where my arm's tired. Promise the jokes will get better as we go on. It's a little early for me. Presenting here, this is a talk that goes back a few years. It's been freshly updated we have a new driver. Is anyone using MongoDB with PHP currently? Were you aware that there was a new driver?
Yes.
We have PHP 7 support now,
Yeah.
so everyone can stop asking for that. So we're talking a little bit about that, and also updated a lot of the content from MongoDB 3.2. So I'm not rehashing something from 4 years ago without putting effort into it. So this is again on Twitter. If there's questions we can't get to today, feel free to ping me. I'll be here all weekend, and I can definitely answer your questions. Happy to have a conversation later. So MongoDB primarily a coffee mug company, but we also make databases. These are the topics that I'm going to talk about today in some particular order. So at the beginning, I just want to talk a little bit about the new driver, if you're starting MongoDB now, why you should definitely use this over the old one. And then get into some of the general topics, which whether you're using Mongo with PHP or any other language, things that you can carry on with in any way that you're using Mongo, or even just a general database. A lot of the topics translate over to other databases. I'll cover a little bit about the reading and writing, quick bit about the deployment. I might skip through some of these if we're a little short on time. And then the object document mapping at the end is basically using like an ORM or something to have model classes for your database entities. So to introduce a new driver, this is a project that, if anyone knows Derek Rethens, writes the Xdebug component, PHP's daytime stuff. So we were working on this for the last year and a half, as well as Hannes, one of the other PHP.NET folks. Primarily it was born out of the old driver, which goes back about 5 or 6 years, longer since any of us have been at the company. There were a lot of design mistakes over the time, so now looking back over 6 years, the extension, there was a lot that we wanted to clean up. So here's a bunch of mistakes with the old driver that we wanted to clean. So if anyone has used Mongo, you know that the old driver gives you back arrays for everything when you get your database documents back. So in the actual database, we have this BSON, this binary JSON format, and it stores documents or arrays. And PHP developers like to work with arrays, so we just gave everything back as arrays. If anyone has done JSON encoding, you know it's kind of it gets a little ambiguous when you have a JSON array or a JSON object and it go back and forth from PHP. You can't always preserve the same types. So some of the other, this is primarily the big mistake we wanted to do, the fact that we couldn't round trip things to and from the database. For some edge cases, was a big problem. And there were a bunch of other curious design strategies. We had inconsistent logging and static properties for INI things that we had added in over the course of 6 years. And in the end, it turned into this big ball of C code that was quite unattainable. So when people were asking for PHP 7 support, it was we can port this thousands and thousands of lines of really bad C code over, or we can start fresh and move forward. And the same, on a similar note, we also wanted to be able to support HHVM, which would certainly not be able to use any of the same code. So to go about this, we decided to come up with one new driver targeting the 3 different engines here. And this is the stack that we came up with. And so where our old driver was really just one Pecco extension that you would install and it did everything. We decided if we wanted to have code running on PHP 5 and 7, the C code would be a bit different. And then HHVM, has anyone played with HHVM or extensions or anything? So in their extensions, it's a mix of PHP or hack their PHP dialect and C++ code. So even a much more different internal structure than PHP 5 and 7. So we wanted to keep these layers as lightweight as possible, but really make a no-frills driver that did just a few basic tasks and move all the higher level APIs like the CRUD methods, the insert, the querying, a lot of the helpers that you find if you wanted to do like list all the databases or list all the collections, drop a database, do an update query, do an insert. So move those all into a composer package. And this way we'd be able to share everything that was written in regular PHP on either of these three engines, since they're all going to be able to run PHP code. It's a little bit of departure from the folks that were used to just installing one Mikola extension and being on their way. But additionally, we gained a lot by being able to now use we had C drivers for things as well. So this stack basically gives us much smaller extensions to maintain, so we can iterate more quickly and hopefully not have to change these much. And then also, since we're putting most of everything in userland, it opens it up to more community contribution. Because the general PHP developer is going to have a much easier time submitting a pull request to a composer package than they would to a technical extension. So this is what we came up with, and just to recap some of the APIs, this may look familiar if you use the mongo.so, the technical extension. We have this client class that you connect to. We can select a database and select a collection to work with. Just dropping, inserting a document. If you've, has anyone not seen the driver before, or just how MongoDB works without? So we're not using SQL queries. We're just inserting. Everything's expressed as objects or documents. In this case, we're just inserting a document with a foo field and a bar. The driver will create an ID for us. And querying looks very much in the same fashion. Instead of having a query language, it's kind of a document structure that has criteria, and we can have operators in there as well, which we'll see a little bit later. And so from the collection, that's where you do all your main operations. And if we were to dump these out, we see that the document, even though it's an object in the database, comes back as an array, because that was our legacy design choice. The new driver is a little bit more verbose. We don't expect people to use this directly because we're going to have a composer package. But the main things that it does, the manager is basically your client that you connect to. And we decided to pare everything down to just three methods. The three main things you would do in any MongoDB driver is run some kind of database command, which can be open-ended. There's hundreds of them. Do a write operation or do a query. So those are now the three methods instead of having a massive class specification of all these helper methods and everything. So really it's just a manager class, some value objects like a query object or something that compose a write that we would then send to the database. And we still have this iterable cursor, which is our database result, similar to like a result set in a SQL driver. And so the one main difference here is that documents now come back as standard class instances, which a lot of PHP developers aren't comfortable with working with these. Like we don't have literal object syntax in PHP. On the plus side, this means that if it comes back as a standard class and we write it back, we know it came out of Mongo as a document, it will definitely go back in as a document. But that's going to be, we anticipate people are going to be upset about that. It's definitely, it doesn't have the syntactic sugar working with arrays. So when we introduce the composer package, one of the things that towards the very end I'll talk about are adding an ODM into the database to be able to say I want certain MongoDB types to come back as certain classes in my database. So we decided to, instead of keeping the old legacy behavior of arrays or forcing people to use standard class with the new stuff, we'll use array objects, and we'll have one for documents and one for a BSON document, one for a BSON array. And they can basically guarantee that when we get this back out of, in this case, the library, you can work with the BSON document. You can use your array access operators as you like. You can use your property accessors if you got used to the standard class stuff. But when we write this back to the database, it knows to make sure it stores it as an object. And the more important thing is that the BSON array type, when it writes it back, it runs everything through array values to make sure that it reindexes itself and stores it as an array. So hopefully the issue with that we would have a JSON encoding or arrays accidentally turning into objects and back and forth would no longer happen. But otherwise, if you look at this API, it's not nearly as verbose as this, and it really looks like the old one. So porting over your code to the new library should not be too much of an intensive effort. So if you're starting today, these are the things that you want to look at. I'll share the slides later. Everything blue is a link, so you don't have to write anything down here. But the new extensions are called MongoDB, both for HHVM, and PHP 5 and 7 are both already on Mikola. The MongoDB/MongoDB library, it's our vendor and our package name, is on Composer, and then we're still supporting the legacy extension, at least for like security fixes and things. So that's not we're not gonna take that down or anything. And if you're curious about this, PHP.net we already added the new driver on there for documentation, and we're starting to add more articles to explain like the architecture and how the ODM stuff works and all these extra features. So admittedly, we got the release out there before having all the documentation ready. So we apologize for that. But we're actively adding stuff more to that now that things have been released. So any questions on that before we move on to, so that's just new driver. If you're getting started, definitely look up the MongoDB extension instead of the old Mongo one. We're trying to refer the old one everywhere as old or legacy to steer people towards the new one. So schema design with MongoDB, a lot of the horror stories are both related to either like doing writes or doing schema design. So the goal here of these next two sections are to provide some just like best practices to avoid yourself one day running a Hacker News post that says I lost all my data or everything, the performance went to crap for some reason because I made schema design choices. So the first topic to talk about, I guess, is in MongoDB's case, unlike we don't have the same query language that SQL has. To making do without joins, so I mean, over the kind of inherently, everyone acknowledges that MongoDB and many other non-relational databases don't have joins. They don't have the full query flexibility that you find in a SQL database. So that requires different schema design decisions to when we're working with document structures. So typically, you'll denormalize data more. You'll embed things instead of having references for everything. So instead of storing IDs, like in this case, if I was like doing a dumb little social network, if I had two friends and I was storing their IDs, if I frequently needed to render my friends list and then show my friends and their names, I'd be much more inclined to just denormalize their names here. Those values probably won't change too often anyway. And that way, when I do select an individual user out of the database, I have the names there as well. And so this avoids, whereas the alternative would be either selecting a bunch of users, collecting the IDs, and doing an additional query for all of them, or in the worst case, the n+1 problem where every time I iterate through friends, I have to do a lookup for each user to get their name. So those are things that we want to avoid. So this is something we can solve with from a schema design standpoint. It definitely involves more storage. And if these are values that frequently change often, there's a trade-off of every time we denormalize something, just like you would do in a SQL database. Every time we denormalize, we have to make sure that it's kept up to date if the value changes elsewhere. But that is a kind of just a given of something that we have to do given the constraints. So we'll see something to say about this in a few slides when we talk about reading. But this may no longer be the case. There's a way to get by with this now. But this is generally the schema that you want to start with to avoid doing those kind of lookups. And in the same way, things like array lengths or counts, if you're keeping track of sums like the number of friends. So we have the array there. When we fetch the user, we know how many, we can count the number of friends. But if it's something that we want to index on, we want to sort or query on it, it's often a good idea to keep track of those computed fields or the counts. Same way, just so instead of denormalizing data that you find in other collections, this is kind of caching the data or caching counts or properties about your own documents. So thing like num friends, and then every time I added a friend, I could also just increment the num friends field. And then I could easily also just do it, if I index that, do a query and find the people with the most friends and whatnot. And generally, the storage itself should be cheap. What things we want to optimize are the querying speed and hitting the index and things like that. So this is generally, we should be inclined to start in this position instead of trying to compute things on the fly later. Another common design mistake that I would like to steer you away from, and this goes back to an old Symphony project that I worked on. We're doing like a message delivery system. And for every message we tracked, if a certain participant of the message had seen the message, so we can do like notifications and stuff. And this was problematic in Mongo because for querying purposes, your field paths are basically in your document this is a top level field name with an embedded object. And so these are actually 5 unique fields, is read by participant dot in the ID string. And so it was really difficult to want to index this because indexing depends on individual field paths. So to index this, we need an index for each of these 5 IDs, which is really, you see why that would be a really bad thing to try and attempt to solve for. But thankfully, when MongoDB allows you to have arrays of objects or arrays of values in your fields, when we index arrays, we're allowed to, it just inherently indexes all the things inside the array. We call that a multi-key index. So we still get away with creating one index, even though it will track multiple values inside of it. So if we revisit the same bad schema from the previous slide, instead we're just tracking, let me just collect a bunch of the IDs, or these could actually be object IDs instead of strings here. I can collect them, and if I wanted to do a query, I can just search where someone's ID is inside an unread for participants array. In that field, I'm using one index, and that would each index entry for a document would then have 3 bucket entries for it. So I get away with one index, and it's much more efficient to search the entire collection and find me, if this is my user ID, find me all the things in the message collection that I didn't see yet. And it would all just use one index. On the same token, this comes back if you're doing something like e-commerce or have like EAB tables where you need dynamic attributes. You can back yourself into a corner the same way with MongoDB because it will allow you to create as many fields as you like. So if you, this is a really concise example, but let's say you were doing all sorts of products. So you have a t-shirt, you have sizes and colors, but you're also storing kitchenware. So you're saying that there's a frying pan or what was the pan diameter, and you're also storing pants, so then you have like length and things like that. So you can see the properties just totally expanding, and then from a querying standpoint, you have all these dynamic field names. From an indexing perspective, you have many more properties that you might want to track. So this doesn't go well at all for just having as few indexes as possible and making your queries function much more similarly. So a more efficient approach to this is, like, again, taking advantage of multi-key indexing, we can have an array and store, as long as the field names are the same, we can index, in this case, attributes.k, attributes.b, and be able to search for, find me all documents where attributes contains an element where the key is size and the v is large. So looking for a size large, still making use of just one single index on attributes.
So you would make that a multi-key on K and B?
Yes, so the question is, would I make a multi-key at K and B? We'll have the multi-key, we can index one array at a time. So we can never index two arrays at a time because it's a bit of a Cartesian product. But if we're indexing, if we index just the attributes field, then it's actually indexing the entire document, probably not what we want. But we can get away with indexing attributes.k and attributes.b. Since they're in the same array, it's still considered one multi-key index, even though we get to index two distinct values inside the objects. Good question. And then alternatively, this is a schema that Derek used. So Derek also works on OpenStreetMap a lot. He has a blog post that he did, I linked to in a bit, for importing all their data. And they have like free-form fields of venues that people add, like open Google Maps. They add arbitrary criteria like this is a pub, or these are the open hours, close hours, what kind of menu, is it a vegetarian restaurant, whatnot. So in his case, rather than go with this route, he decided to store an array of strings and just kind of like a key equals value. And so you can use index just attributes and then use something like regex and say, give me everything that starts with size equals something, just to find maybe all documents that even have a size attribute. Or search for size equals large as a whole string and find something that has an exact match. So these are two different approaches you might do. There's a few more as well. But generally what you want to steer clear of is just creating field paths, just on an ad hoc basis. And this kind of also goes along with tree structures. In this case, I'm keeping the same field paths, but I'm going arbitrarily deep. So it's still the same problem where I could have maybe just too many fields. If this becomes a large tree, like a product hierarchy, in this case it's just a book subtext. So a better approach for this would be, let's just we'll break everything out into separate documents. So we say this is American literature, and every time we just store where our parent is. So across the entire collection now we have the concept of we can recreate the tree. This makes it easier to query for what bucket we fall under. But maybe we still want to query for an entire branch, so I want maybe everything under American literature. So another approach we might do for this, instead of just storing our parent, we can store the path from ourselves up to the root. And then again, indexing on path here with the multi-key indexing. If I just search for where path is American literature, I'll find all three of these because they're all considered American literature. Just search for 1920s, I'll pick up, I won't pick up the top level root, but I'll pick up 1920s and Jazz Age because it's in the tree. And the other interesting things we can do with this are if we also want to index maybe like path.0, so we can index the first array element, or path.1, that would give us essentially the parent. Path.0 is ourself, but we can index path and have a separate index for a particular offset inside the path as well. And we'll consider that our parent would always be path.1 if it exists or not. So that's generally what your solution for having too many indexes are usually rejiggering your schema to have either multi-key indexes or just consolidating your field names to impose more structure. So the two things that you want to do, even though Mongo gives you full schema flexibility, you want to create schemas that best support your query patterns and then tailor that to the number of indexes you create. Because there's a trade-off of, you don't want to ideally not have one index per query. You want to have indexes that support multiple queries. Additionally, compound indexes are indexing multiple fields at once. The same principles with SQL databases apply there. Read-write ratio, so the more indexes you have, every time values change, we have to update indexes. So if you have a collection with 40 indexes, every time you change the value of one of those indexes, we have to not just update the document itself, but all 40 indexes that are maybe tracking that value. Query selectivity is don't create, so a commonly bad index in any databases maybe is deleted or is active or something. So something that's not selected, if it's 90%, 95% of your documents are going to have the same value for this, it's not a very selective index. So you want values that actually drill down so that we can use the index to narrow down the amount of search space that we actually have to do when we look on the data in the actual collection or table. And 2 ways not to shoot in the dark, and these are things you might want to follow up on. So profiling slow queries. This is something you can set and forget in production. Just say, I want Mongo to track all queries that take longer than say 50 milliseconds or 100 milliseconds, and we'll get logged off to a collection. And you can turn on logging for everything, that's what you wouldn't want to do, but the threshold mechanism is safe to use in production. It doesn't have much overhead. And then explaining your query cursors, similar to you would do in a SQL database by explaining your queries. See what indexes get used, see what indexes are considered, how selective each one is. And in addition to queries, the newer versions of MongoDB, you can explain your aggregation pipelines and some of your other commands like counts and other operations. Whereas explain was previously just for queries. So there's a wealth of more content here to explore if you haven't looked at it in a while. And then more links to follow up on if you're using it for analytics. John Newmaker was previously at GitHub, has a great presentation on his schema for kind of doing like a web analytics company. Derek's article on OpenStreetMap data, so the key value stuff. And then our manual has a bunch of use case documents on different, so if you're doing e-commerce or you're doing like a blog with comments, just different schemas to explore kind of like in a prose fashion to walk through. And let me just quickly check on that. So the next thing I want to jump into, so once you come up with initially, your schema is going to evolve over the course of your application, but initially come up with some schema that you think works for you, and then tailor it later. The one thing I guess I missed out on the slide, the newer versions of Mongo also have schema validation. So you can actually have kind of a criteria object for a collection and say all documents in this collection should always match this criteria. Kind of validate if you want to say like the username field should always be a string type. Or this field should always exist. So that's something that you might want to get into with, so even though you have the flexibility to add new fields, there's certain fields that you might want to just guarantee are always set properly. So the thing to look up there would be called either document validation or schema validation in Mongo 3.2 to look up. But getting your data into MongoDB and keeping it there to make sure that you don't end up on Hacker News. So one method that we kind of are getting a little bit of flack with in the new drivers, we had this save method. Has anyone used the Mongo shell before and you save, or you query for a document, you just write it back. And so we got rid of the save method because it was a really overloaded thing that a lot of people didn't understand how it worked. And people think when they get a document, they update a field, they just change one field and they save it back. It's easy for people to think, oh, well, it just writes back that one field that I changed instead of overwriting the entire document. So what save actually does is you'd save a document, it would check if it had an ID. So if it was a document that you might have just queried out of the database, played around with the JSON a bit, and then threw it back in, it probably did have an ID. So then we would take the ID and do an update to update the document with that ID and just replace the entire document with whatever you're passing in to save. And generally, you don't want to do replacements with the database. If you have multiple threads or multiple PHP requests all operating on the same document and each one queries for something, modifies a field, and writes the whole thing back, they can easily clobber each other. Innately, there's no pessimistic blocking at play here. If there was an ID, we just do an insertion. Inserts are safe. We're creating new documents there. But generally, we want to get rid of this because it was an overloaded term. It wasn't clear. It wasn't explicit. And just based on this branching, we're either doing an insertion or an update or replacement. So two very different things happen here. And your return values are also very different. An insert result is a little different than an update result. So we decided, and this was convenient for the PHP drivers since we were making a whole new project. So we were free to selectively decide what APIs to drop completely. So over the course of last year, we came up with a CRUD specification for new drivers. So even though every driver had insert, update, query, and delete methods, we decided to standardize them, their namings, the options that you would have for each of them, and whatnot. And so the new PHP user library, we just decided to just implement this. And so previously there was an insert method, and the two ways you'd use that are insert one document or insert a bunch of documents. They also have different results. This would return, say we generated one ID or we generated multiple ones. With an update, you might be doing an in-place update with atomic modifiers where you're just setting specific fields, or you're doing a whole replacement, which is what save does. Where you say, this document, I just want to overwrite whatever's in the database with all these, with what I'm passing in. So we broke that up as well. So now, previously you might be looking at a piece of code that just calls update. And you might have to refer based on the options or the argument. If I'm using atomic operators like $set and $inc, or am I passing in just a flat BSON document that just gets, in that case, that's how I know I'm doing a replacement. So having more descriptive method names is, I think, an improvement from self-documenting code with these. Same thing for remove. These curiously, by default, update would update one document, and remove would delete many things. So this inverted, one did many by default, one did one by default. So again, having more descriptive method names, now just looking at it, you don't have to think, is this deleting everything or one thing at a time? So it's maybe a little bit of a pain in the butt to port your code over from these method names to the new ones, but hopefully that's a month from now after you do the search and replacing, you'll be thankful. So on that note of why you generally don't want to replace things, this is the example I said. If I'm finding Mikola and I'm pushing Pablo Vidal into my friends list and I replace the entire document, if there were two of these happening simultaneously, one's going to overwrite the other. Whereas internally, MongoDB will let me use these operators and send a write that just says, just basically send the append to the array command over to the database. It's this way, I can have 50 threads all doing the same pushing, and they're each going to be appending to the array, and no one's going to clobber each other. Granted, I could end up inadvertently adding Pablo Vidal twice, in which case there's an add to set function operator I can use instead to treat it, so that it wouldn't add him if he already existed in the array. But generally, you want to use atomic operators where possible. And a note on how atomicity works in Mongo. So there's no transactions for operating multiple documents. There is no begin transaction, rollback stuff. We have a write-up on how you might emulate this with two-phase commits, but it's not the same thing you're going to find in a SQL database. So to be upfront about that. When we're working with a single update, when you're modifying a document, basically everything you're passing in here, all that criteria does get applied atomically. And if there's a case where we need to query an update at the same time, we have a command where we can query for something with some sort criteria and apply an update to it, whether it's a deletion, a replacement, or an update. And this will also return the document back to us. So another benefit of the CRUD API, previously it was just called find and modify. And there would be three very different modes that this would operate on. It would be doing a deletion, a replacement, and an update. So the CRUD API, consistent with the previous renaming we did, we have more descriptive method names of this. So another fellow opened a ticket and said, where did the find and modify method go? And I said, these are the new three methods that you ideally should be using, and it's more descriptive of what you're actually, what your code will be doing. And generally, the benefit of why you might use this over, you could say if I just want to do updates or deletes, I don't need this, but it really comes into play when you're doing sorting and you want the document returned back to you, because updates and deletes normally don't allow you to do that. So we were to insert, say, some task to be done, and initially it hasn't been approved, it's not pending as a default priority. In a sense of a job queue, maybe you want to select the highest priority task to do and then claim it as maybe it's in progress or we're looking into it. So a very dumb library application here. So I might look at all my incoming loan requests for library books, say it's look for things that aren't pending. If I find something that's not pending, I want to claim it and say, no, I'm looking into it, so I'm going to set it to pending. I want to get the new document back, and the thing that makes it, the main benefit here of find and modify is I can sort it and say, give me the thing of highest priority. So I can kind of pluck off something off the job tree and work with it atomically. And so this is what you might also use for if you may be implementing a ticketing system where you're multiple people competing for seats in a venue, something like Ticketmaster and things like that. If you're implementing any kind of limited inventory stuff in MongoDB where you want to be able to have people claim stuff and get it returned back.
So what happens at the moment that the query returns with multiple values?
This would always just return one thing.
In this case, right? But,
Yes.
But if you run a query that returns more values.
So it's possible that there will be multiple loans, but the benefit of find and modify is you want to operate with one thing at a time, because we only atomically work with one thing at a time. So this is selecting one document that matches our criteria. and just operating on that for now. So in the sense of a job queue, you would just run this in the background process, and it would constantly churn and try and feed for the next document to work on. So if you wanted to operate on multiple things at once, you can do like mass updates or mass deletes, but they wouldn't all apply atomically, because there would be multiple documents that work there. So note on write concerns. So the old default, and the bane of our early reputation, was drivers doing write operations and not waiting for acknowledgement from the server. That's been fixed for years. A large portion of the internet doesn't seem to care that we've changed the default years ago, but it has been changed. But generally, you don't want to go beyond this. If you're writing data you really care about, you probably want to make sure that it gets applied to the majority of, if you're hopefully running replication, make sure it gets applied to the majority of your nodes, which means it can last through failovers if you lose your primary, and that was the only node that had acknowledged it, then the data might be rolled back. So the really important stuff, you have higher levels of write concern, of how concerned are you that this will be persistent. And additionally, journaling is also at play. So even though, and this also relates to SQL databases, so a lot of them will have a journal where the data that you're writing to disk will immediately go to memory. We'll make sure that it succeeds, passes through the indexes if it's a unique value or not. But as far as actually surviving somebody pulls the plug on the server, unless it's actually committed to the journal, where the next time you start up the database, it can again get, once it's journaled, it's on disk, even though it's not in the actual data files where it ultimately belongs. But if it's journaled, at least we have the data can be permanently recorded there and survive a restart. So that is certainly an option with write concern. The whole trade-off here is the higher you go, and if you have journaling, your writes will take longer because you're waiting for more commitment on the server side. And so that's why this is something that you can tailor per write. So if you're doing something like logging, you probably don't care, even if it's logging 0, there's no unique indexes, you just want to dump the stuff as soon as possible. But if you're doing something like emulating transactions or doing some like e-commerce stuff, you probably want to go steps higher and make sure the data is fully committed and will survive restarts. And there you're willing to wait a bit longer because those are kind of user-initiated actions that this passive bulk insert happening in the background. A note on document growth. So this is less relevant today than it was 4 years ago because now we have different storage engines. But the original storage engine, every time you grew a document, it may have to relocate on disk. And every time we would have to move documents around on disk, we'd give them some breathing room, expecting that they might grow a bit larger. So the takeaway here was, and this comes into play with things like analytics, where you're like logging more data to document. If you had a document that was tracking, say, web stats over a day and things like that, you'd want to create the initial document with kind of like a flat structure that you would then kind of create it at its maximum size once, and then just update integer fields throughout the day. Any kind of documents where you were constantly appending growing arrays or making strings longer, things like that, would lead to the documents keep shuffling around on disk and leaving kind of like a fragmented file system behind, which may or may not be used to fill smaller documents later. The newer version, which is the default storage engine in 3.2 and forward, uses a whole different mechanism for storing things, so the document growth isn't really a problem. Every time, so the new thing is called wire tagger. Every time a document gets updated, it creates a new snapshot of it on disk, and it's going to occupy different memory. And so that's part of its MVCC structure for just keeping track of the documents, and the previous version is still kept around, which comes into play later, as we'll see, for querying as well. So generally, unless you're using an older version of MongoDB, this is still relevant. If you're using 3.2, then you're using this storage engine by default, and then this is not something that you really have to worry about. And I will say this is also where the document level locking comes into play. So we no longer have, excuse me, no longer have database or collection level write locks. It's now so much higher concurrency if you're in a high write scenario with wire tagger. So on the flip side of getting the data back out of MongoDB, so two things to know. One is to have indexes for things. There was somebody this week that was in IRC complaining about very high CPU usage. He wasn't running any stats, he wasn't running our monitoring service or anything like that. Wasted a bit of time walking through this with him. In the end, he was running things and they didn't have indexes on any of the queries. And so that's why all of his MongoDB threads were maxed out, because they were all scanning the table data. So that's the first thing, and that's where explaining comes into play. Taking your queries, explaining them, see what indexes they're actually using. And secondly is to know your working set, which is your working set is basically how much data I may have gigabytes or terabytes of data in my database. What's the percentage of it that I actively use? So for Twitter, that's maybe tweets in the last 4 or 5 days, even though they have stuff going back 10 years. So your working set varies based on your use case. But this will tell you how much you can get out of your hardware, and this will certainly something you should be doing anyway. So the more indexes, more active indexes you create, it increases the size of your working set as well.
Do you have an actual tool to tell you what working set is, or is there a
there are estimated tools. There's ways to derive it. It's more documentation. There is not a one tool that you just run and it competes it for you. If we find a way to do that, we can probably make money off of it. It would be very helpful, but it's generally, it kind of needs like a tailored investigation into the application to take measurements and things. And on the reading side, so the write concern is like when I write stuff, how much do I want to be acknowledged by the server? On the flip side, when I read from things, who do I want to read from? So if you're just running a standalone MongoDB just on your local machine, this is not really relevant because there's only one node anyway, so you're reading from the primary, the writable server. But otherwise, you have some options here, and generally, some people immediately go to say, I'll read from the secondary servers and the replicas to take load off the primary. And generally, that's not really necessary. Like you don't really, if they're doing that, it's maybe because they don't have indexes at play. And so this is kind of their indirect solution to not the real solution that they ultimately need. So usually the primary, if it's capable of keeping up with the writes, it can also handle the reads for the same data. But this gives you more flexibility with, in a large environment, you may have things in multiple data centers. So you might just want to read from the nearest one with the lowest network latency. And additionally, with replica sets, we can annotate members as tags and saying, well, this node lives in a certain data center, or this node is used for reporting queries, or this node has SSD disks. So different ways that we might want to annotate things, then give a read preference, say, I want to select a node that has this metadata attached to it. I want to do a query from the SSD node, or from the node that is running has a lot more RAM, because I know it has more indexes in memory. And on the flip side, one of the newer features in 3.2, and this is something specific to, so I mentioned WireTiger has this snapshotting it does. So every time you update a document, it keeps it creates a new version of it in the multi-version concurrency control design that it has. And so the old snapshots of it are still kept around. Read concern is similar to write concern. This lets kind of the inverted but by default, it's just when you query for something, you just ask for that node, give me the most recent copy you have. But with WireTiger, since it has the snapshotting built into its design, we introduce, currently we introduce one extra read concern here, which is the new one that people may want to use. This is saying if I issue a query to the primary, I don't necessarily want the latest data from the primary, I want the data that the primary knows that the majority of people have. So it actually may be a little bit stale, it may not, so it's not going to give me data that hasn't been sufficiently replicated yet. So this is convenient to make sure that, the same way with write concern majority, I only write data, and after the write is acknowledged, that means that it can survive a failover. This is saying whenever I do a read, if I only want to read majority data, I'm reading data that will also be there after a failover. So I never kind of read stuff that might be too new and might not survive if the primary immediately goes offline. So this is all very new, as of just like 2 months ago. And this is, again, something that it's going to make your queries a bit slower. They might return slower. But you would reserve this for the most important data that you don't want to risk reading data that may not survive or may get rolled back. So it's anything like transactional data or user orders, things like that, you would feel comfortable applying this to and taking the slighter performance hit. Whereas for most things, the default is to just give me the latest data. And so this is sort of only on WireTiger since it's built into the storage engine. JavaScript evaluation, the same question is, would you use a valid JavaScript or PHP? Probably not. Don't use it in Mongo. It's there. It does show up in MapReduce, which I'm not going to get into because there's the better thing to encourage use of is first the aggregation framework. I could give an entire 60 minutes on MapReduce and not really get anywhere with it. This is much more straightforward. It's the aggregation framework. Mario is a document, and he's going through these pipes, and each of these pipes is a different stage of your operations that you want to apply. So they might be doing groupings, they might be doing projections or matching criteria. Think of it as in the command line when one Unix command pipes its standard out into another command standard in, and by the end you end up with some munged data through all your filters. So that's basically what the aggregation framework does. So if we had some books here, let's say His Majesty's Dragon is a historical fantasy book. Yuri's going to recognize I didn't use the original name that we were discussing yesterday. And this was published in 2006. So I have documents like this in my collection. And normally with MongoDB's querying, it doesn't do accumulations or aggregations. It's not built into the query language. The aggregation is one of the database commands that it can do the same things querying does, because it does have a dollar match and dollar projections, which are can you select which fields I want and then certain criteria. But additionally, it also adds in aggregation-related operations. So we create this array of operators. I'll say, of all the books, I want them sorted by their creation time and get them ordered that way. I know subjects is going to be an array, so I want to unwind it. That means if this document, think of this document being a Mario character, he's going to go through a pipe. It's going to get sorted, so the Marios are going to come out in different order. And once we unwind, if one Mario, so this one document goes in, and it has 2 elements in the array, this second operator in the pipeline is going to emit 2 documents instead, and the array is going to be replaced by each value. So we'll get a copy of this document with subject's fantasy, and then a second copy with subject's historical. So it just kind of unwraps the array. And the opposite of pushing things into an array. And then once we unwind these, we then group on them. And so this is where we use the $sign both for operators and then for referring to field names. So we group, we say, when I'm going to group things into buckets, I want each bucket to be grouped by subject, and then I can accumulate other fields, kind of project other fields into this bucket. So every time I see a document, I'll just add one. I'm just keeping a count. And then I want to track the first year that the book was published. And so since things are already sorted, I know that I'm going to see them in order of their creation time. So if I just pluck off the first document that would go into the bucket, I'll access publish as a date field. I'll use this operator to pluck out the year as an integer. I'll take the first one that I see and then stuff it into the first published field. And so your documents all go through this in sequence, and these can all operate in parallel on the much more efficient C++ implementation on the server. And after we aggregate all this, we might end up with something like this. So running the aggregation, we'll say fantasy books. There's 6 books in our tiny little collection here. The first one was published in 2002, et cetera, for other things. So this gets very powerful with doing, again, you can certainly do more with SQL, with aggregations in the SQL language. This was a huge improvement from people originally just having MapReduce or just using basic queries in Mongo. And it's certainly a lot faster because it's not using JavaScript. And remember when I said MongoDB doesn't do joins? Well, hell hath indeed frozen over. And there is a $lookup operator was added to MongoDB 3.2. And so while this is not, it basically does a left outer join on the data. So let's say we had an orders collection, where this referred to the skew of things in the inventory collection. And so you want to select orders and kind of resolve this on the database side into the corresponding documents here. A year ago, we would say, no, you'll never be able to do that. And today, lo and behold, we have this operator you can just plug in as you would any other pipeline operator. And we'll say, it's a little verbose here, we say, so lookup, so I'm processing every order. Every time I see it, what is my local field? So this is item. So my local field, I'm going to look at the inventory collection. I'm going to look at the field, the inverse side of the relationship, the skew field, and what I want to project it into. So I'm going to create a new field called inventory docs, and it's going to be an array because it might be a one-to-many. We don't know if it's one-to-one or one-to-many, so it stuffs into an array. And you'll end up with this on the other side. Some caveats, because there's always caveats. You can use it if uncharted collections in the same database. So this could change down the line, but right now I just make sure that we can process all this lookup on the same MongoDB instance at least. This is obviously, you might assume, not the most efficient thing to be doing server side anyway, because we weren't even originally designing a database with this in mind. This is mostly used for, so I wouldn't start with this. Don't use this in your general purpose application. It's more useful if you're doing data reporting and not running like live queries. I wouldn't do live queries where every web request is running off a bunch of lookups just because you can. It's going to be a lot faster just to do normal queries and put the data together in the PHP stack. But that said, this does exist, so use this tool sparingly with the full knowledge of how efficient or inefficient it may be. But this is still new. I'm sure we'll be improving it down the line. This is how it starts. Let me just check on time. 5 minutes here. So quick note on operations. I'll kind of breeze through this, but different ways you can start MongoDB by itself. In production, hopefully you're doing it as a replica set. And config servers would be if you're using sharding, which means you have multiple, partition your data across multiple replica sets. We have config servers that you would also run. The 2 points which I will emphasize and skip over the rest of most of this so we can talk about the ODM stuff. But I'm happy to talk about this offline. Don't use replication for scaling, because that means if you're doing that, it's probably because you want to send reads to the secondary servers, in which case you're probably going to read stale data. Use it for data safety, high availability. If you have failovers, you can do rolling upgrades because you can make someone else a primary, upgrade the old, and then iteratively upgrade them. Sharding, when you're scaling, it's because if you want to add more reading or writable nodes, that's where you'll do sharding and then you'll partition your data across it. And I'm going to go through a bunch of this, but the 2 takeaways with little animated GIFs, which I would like to get the point across. If you're using sharding and you're not replicating, I'm making an assumption here you probably don't know what you're doing. But if you're using replication, maybe you decide to shard, but the important thing is you're using replication in a production environment. That's pretty good. So, and now, why is sharding good? In this case, we have all this data on one node. Let's say our working set was 300 gigabytes of active data. And our Amazon instance, which we're paying handsomely for, is 96 gigs. With sharding, we can split that across and bring that ratio down better. So we're just making the ratio of what is our working set per memory closer to 1-to-1. And so that's why sharding, replication doesn't do that, because every node would still store the same data. So you'd have the same problem with indexes. So keep an eye on the RAM usage for all that, and happy to field questions after. The thing I want to end on a bit about ODMs. So how many people are familiar with Doctrine for ORM at least, but there's also one for MongoDB, which was finally released this year after much huzzah. So ODMs they come with pros and cons here. The benefit of ODMs or ORMs is you get in a Docker model, you get to use actual classes for your database IDs instead of like raw SQL results or raw documents, arrays in the old driver. They usually integrate nicely with your frameworks. You get the nice command helpers if you're doing like migrations and things like that. And annotating your indexes on the classes and keep your indexes in sync. Really quick for bootstrapping a new application, because you can just create your model classes and then the documents can just, if you're using an ORM, it can create the schemas for you. But it abstracts the database layer. This is where things get tricky because it makes it possible to use these without actually understanding what happens underneath. So in the case of like an ODM for Mongo, maybe people would immediately jump to using references for things and then having the n+1 problem because every time they resolve a relation, they have to go do an extra query versus embedding things by default. And so the important thing is to first start learning the DB and play with the raw driver itself, understand how the database works, and go through the other exercises of schema design and reading and writing before picking up an ODM and trying to use it with any database. And to quote one of the greats, Martin Fowler, if an ORM does 80 or 90% of the mapping problems, there's still that other 10%, and that's what, or 10 or 20%, that takes someone that really understands how the database works to get the most out of it. So if you look at the talks from some of the Doctrine guys like Guillermo Blanco, one of the ORM contributors, he has talks of using ORM and then not having problems with it because he uses it responsibly. And I mean, he's a developer on it, so you hope at least he's using it responsibly if no one else. But it just requires certain responsibility to be aware of what's happening underneath and understand the things that it's good at and the things where you don't want to use it for everything. And the new driver, 3 more slides here, and then we're good to go. We didn't want to add, this is not a replacement for what we do in what you do in Doctrine with, it has a lot more, Doctrine offers a lot more features than other PHP ODMs. But we want to add a new driver, which is some way to more efficiently do mapping from data coming out of Mongo into PHP classes, because that's something that's kind of inefficient in Doctrine because we get these arrays back, or in the new driver, you get a standard class back, and then you have to iterate on the fields and copy them into class objects and use reflection and things like that. So we do this in the extension in C or C++ for HHVM. Make this a lot more efficient. Is that the 5-minute warning or the?
That's the time.
That's the time's up. Okay. Maybe 2 more minutes.
Right.
Maybe 2 more minutes. Okay. So we have this person class. We have some interfaces that we created. One is persistable, and this is basically we have. If anyone's familiar with JSON serializable in PHP, You have a JSON serialize method, and it returns what fields you want to write back when you encode as JSON. So persistable does the same thing. It just means it's serializable and unserializable separate. It encompasses both. So in serialize, we say use the fields that I want to write to the database. And so I'll return these in unserialize. This is the data that comes out of Mongo back to me as an array, the document data, and I can fill in my properties. And so the driver will take care of this, and it actually injects, when we store this, it injects this extra underscore or something, don't worry about what the name is, field into the database and with the class name. And so we get it back out, we then check if the class name exists, and we'll create a person object for you. In the general, just if you do an insert, you insert this person object, and you do a find query later, you'll get a person object back, as long as the class still exists.
Is this the Mongo hydrator?
Was that the project by Johannes?
No, is
The
this is.
Oh, this is built into the driver. Yeah, they're built into the
Call
driver.
it a hydrator?
You could call it a hydrator, yeah. And so it's not like a full ODM thing. It's more of a hydration and persistence layer. There's a big article on the PHP.net documentation of how this works and how you can configure it and all the edge cases of like what happens if the class doesn't exist and all this stuff. So it's very predictable. We wrote a specification first before we implemented it. How we use this in the new driver, I mentioned that we wanted these array and object classes so that we can round trip documents and arrays back and forth. So the two things in the library, the defaults for arrays and objects, and so we're not persistable because we're not saving the class to the database here, but when we write a BSON array, so we use array object in PHP, we write it back to the database, we run it through array values to make sure we index things, and so it becomes a BSON array. So we get rid of the gaps in the array keys. Because gaps in array keys is not a list. Basically, it would become an object. And when we unserialize it, we just construct the document. Same thing for a document. When we serialize it, we make sure it becomes casted to an object. So if you had a document with the field 0 and the value foo, if we were to write that out as PHP, it becomes an array because that's the key 0. So we want to make sure we cast it to an object so it becomes a BSON document. So this is they're very simple 3-line classes basically, and we use array objects so you get to use all of your familiar array offsets and property access for these things. And hopefully people don't even have to realize that this exists. They'll just feel very much like the old driver without that caveat, or without that edge case that sometimes arrays become objects and vice versa. So thanks for that. I forgot to add in the joined in link, but it is on along with all the other talks. So if you have any feedback, I'll pop outside so the next speaker come in. But thanks for joining.